Hey guys, let me just go through this and tell you how to um, do these review problems. So first of all, we've got this Claire problem, and we have to do the sign of the displacement, force, and work. So if you look at this box, it goes from 1 to 5, and it's going to the left. So the displacement is always negative, because negative means left, and that's good. It doesn't stop until 5. You can see it says 3 meters per second, 3 meters per second, a meter per second, 2 meters per second, and then finally stops at 5. So it keeps moving the whole time. For force of Clara, we have to look at the direction that she's pushing in. And so she's pushing to the left, except for here, which is she stopped pushing at 2 and resumed at 3. So she'll have 0 between 2 and 3. But everything else will be negative. And then we're going to use W equals F parallel D. Sorry, it's taking me a while. There we go. To figure out work of Clara. So a negative times a negative is a positive. Oh, those are weird. Okay. A negative times 0 is 0. A negative times a negative is a positive. And then again, a negative times negative is positive. You know what? I think I should just type. I wonder if I can type in here. Oh, well, that's much easier. All right, force of friction. Friction opposes the motion. So since the motion is negative, force of friction is going to be positive. And then that means that work of friction is going to be a negative times a positive, or negative, which makes sense because work of friction is always negative. Force of gravity always points straight down, so that's the negative direction. But the displacement is going to the left. That's where the D is going. And force of gravity is going down. Oh, so that's the D. This is F, G. Woo. So those are not parallel. So that means gravity does 0 work. Okay, last part, W net. To look at net force, we need to see the overall energy. Is it increasing, decreasing, or staying the same? And since there's two types of energy here, there's GPE. Actually, there's not GPE because it's on the floor. So the only type of energy is kinetic, and we can tell if kinetic's going up, down, or staying the same based on the speed. So from points 1 to 2, the speed stays the same, so the net force is 0. From 2 to 3, the speed slows down, so the net force is negative. Or the network is negative, sorry. From 3 to 4, it speeds up, so the network is positive. And from 4 to 5, it slows down, so the network is negative. So that's number 1. Okay, number 2. Number 2 has to do with, let's see, which choice will rank the work done by the box. So we know that, whoops, parallel forces do work. And we know this box is going to move that way. So the whole 50 is doing work on this guy. Here, in part B, it's just that does work. The X component. Oh, I wish that was better. And then over here, it's also just the X component that does work. So we know A is going to be the biggest one. It's going to do the most work because the whole 50 is going towards the work. So that means we can get rid of this, this, and this. And now we just have to figure out if C is going to do more work than B. This is a little tricky. This is a little math. Let me just, but if you do, let's see, we're looking at this part. So this would be 50 cosine 15 down here. And this would be 50 cosine 40 right here. Hopefully you can figure out that like when it's a steeper angle, there's more force going down than there is when it's a less steep angle. So that means less force going this way. So basically it goes A, C, B, which is answer number part C. So it's that one. The last one, the normal force, what we know is that if you push something into the ground, that increases normal force. So B has the most normal force. So we can immediately get rid of all of these. And we know when we lift something up, like we're doing in C, that decreases the normal force. So it should go BAC. So that's this one right here. Okay. And the last one. Well, this isn't the last one, is it? Nope. Okay. Oh, it's going to be a pain in the neck. So this guy here. We've got a 15 kilogram box going down, and it's going at a constant speed, which means F net is 0. Here we've got force of gravity, and these are the two components. People are confusing this for some reason. They're calling this force applied, but it clearly says force of gravity, and then these two things you should recognize as component form. So force of gravity is 150, but that goes straight down. We want to use the component forms. This is the part of gravity that goes perpendicular, that 120, and then this 90 is the part of gravity that's pulling it down the ramp. So when I draw my free body diagram, first of all, it needs to be tilted like it is on the diagram. Okay, that one should be F, G, oops, and I'll call that Y. And that's, what is it, 120 newtons. And over here, no. And this guy over here is FGX, which is equal to 90 newtons. Well, you can't really see that, can you? There we go, now you can. All right. So we knew F net is equal to 0. So that means we've got two other forces. First of all, we should have normal force pointing up and perpendicular. So that's here. That's why they give you the perpendicular part of this force. And then we should have friction opposing the motion. So our F friction is equal to 90 newtons. And then over here, we've got F normal, which is equal to 120 newtons. Oh man, this life is tough over here. Hopefully you can read that. All right. For the next one, we've got this same box and it's sliding up the same ramp. So right away, what we know about that is if the two surfaces are the same, then the friction is the same. And it's going at a constant speed, and the friction is pointing down this way now. So let me start. So I'm going to draw gravity in again. Those are the two component forms of gravity. I'm going to draw friction pointing the same way as the parallel part of gravity. I'm going to draw normal force. And then we've got to draw the pulling force. So it's a constant speed. So that means F net is 0. So let me go. All right. So let me go down. This here is my F. There we go. That's my FGY of 120 again. And then we've got an FGX again. Oh, of 90. So that can go here. And then what do we do? This right here is our F friction, and that's also 90. I'm going to go over there. This is my normal force, and that's 120. And then this guy here has to balance out the FGX plus the FF, force of friction. So this pulling force has got to be 180. Oh, shoot. In order to balance that other stuff up. Uh-oh. All right, we're going to stop because of this. I'll be back.